So we're discussing how to shift these functions that we've been learning about. So when we shift a function, all we're doing is moving it around the xy plane. And when we shift it, or when we move it, the location changes, but its shape does not change. So we're just literally taking it and moving it around. A function can shift either vertically, which is up or down, or it can shift horizontally, which is left and right. So different things affect our shift. So if I want to shift it up, that means I'm moving it up along the y-axis. And what I'm doing is I'm taking an equation, for example, x squared, and I'm adding a number to the entire equation. So x squared plus 1 would shift the graph up 1. And if I wanted to shift it down, it would again move along the y-axis, and this time I would be subtracting a number from the entire function. So if I wanted to shift x squared down 1, I would write it as x squared minus 1. So this will shift down 1. Now, shifting it left and right gets a little bit trickier, and this is something you just have to be really conscious about. So if I want to shift it left, then I'm moving it along the x-axis. And this is the weird part. I am adding a number to each x in the function. So notice that this time my plus 1 is in parentheses. Okay? So anytime you have a number in the parentheses, you're shifting it left or right, and it's the opposite direction. Typically when you think plus 1, you think you're moving it to the right one, but in reality a plus 1 is going to shift it left 1. And the same is true that if I want to move it right, I'm again moving it along the x-axis, but to the right means I need to subtract a number from each x in the function. So that's why there's a minus 1 here. So minus 1 in the parentheses means that I'm shifting it to the right 1. So you may want to write this down. So if I write the function y equals x minus h squared plus k, this h here represents the horizontal shift, and it's always the opposite direction of the sign. So that means if it's a minus sign, I'm moving it to the right. If it's a plus sign, I'm moving it to the left. K on the end here represents our vertical shift. And it makes sense. If I have plus 7, that means I shifted it up 7. If I have minus 4, that means I shifted it down 4. But that's what these two numbers mean. So it says for each graph below, it shows the function f of x shifted. Tell which direction it shifted and how many units. If I look at this function here, the graph of x squared is going to look something like this, with its origin, its vertex at 0, 0 at the origin. Well, this graph here, this one that's blue and now it's pink, has been shifted up 3. The next one has been shifted down 3. And I know it doesn't ask you to do this, but we're going to go ahead and write these equations. So if I wanted to shift x squared up 3 units, all I have to do is add 3 to it. And if I wanted to shift x squared down 3 units, all I have to do is subtract 3 from x squared. For the next one, I have shifted this one to the left 3 units, and what that's going to do to the equation is it's going to change it to y equals, in parentheses, x. Instead of left 3 or minus 3, I put plus 3 because it's always the opposite squared. So whenever you shift it left or right, it has to go in parentheses with that x. And then the other one was shifted to the right 3. And again, I've got to put that in parentheses, so it's going to be y equals x. Write 3 instead of plus 3, I put a minus 3 because it's always the opposite sign. So y equals x minus 3 squared. So it says for each graph, use the graph in its description to write the equation for the shifted function. So I have this function here, which started out at 0, 0, and it tells us it shifted down 1 unit and then to the right 2, and that's where our new vertex was. So if my equation was x squared, it tells us that is f of x equals x squared. Well, now I've got to account for these shifts. So I'm going to start with the right and left because that's going to go with my x. So if I went to the right 2 units, that means it's going to be x minus 2 in parentheses, then squared. And then if I shifted it down 1 unit, that means it's going to be minus 1 on the end. And if you want to, go ahead and check this. Graph this in your calculator and see that it really does look like the graph on the right. So the next one tells us that it was shifted up 3 units and to the left 1 unit, and that's where the new vertex would be. So my function, f of x, is now x, and then I start with my horizontal shift, which was my left shift. So a left shift tells me I'm going to add 1 with x, inside with x, and then my other part is it shifted up 3, and up 3 tells me I'm going to add 3 on the end. So remember, whatever goes on the end, the sign is normal. The sign stays the same. And whatever goes in the parentheses is always the opposite sign of what you think it should be. Always. And this will always be the case. It doesn't matter if it's an x squared or an x cubed or x to the fourth or square root of x or x to the negative second. If it's in the parentheses, it's always the opposite sign. If it's on the outside, it's always the normal sign. So I'm writing some equations based on the graphs they give me. So for number 1, it says the graphs below have the same shape. Write the equation of g of x. Well, I need to figure out how they got from f of x to g of x first. So it looks like they went up 1, 2, 3. So they moved it up 3. So that means g of x, it's going to start off the same. It's going to have that x squared in there. Because I moved it up 3, I need to add 3 to the end of it. I'm going to do number 2 because we have not looked at one like this. Number 2 is a cubic. It doesn't change the way we do the problem. It just means you need to pay attention to what our function is. So our original function was f of x equals x cubed. It started out at the origin, and then it moved down 2 this time. So that means that g of x equals, it's still going to have the x cubed in there. And since I shifted it down 2, that means I need to minus 2. So number 5 is going to be the same problem. This time my function was x to the fourth minus x squared. That's what this black function is. And then the dotted line is going to give us g of x. Well, g of x, it looks like, was moved down 1, 2, 3, 4. So that means I need to subtract 4 from the end. So I'm going to have g of x equals, it's still going to have all the same pieces that f of x had, but it's going to have a minus 4 on the end. Number 7, you have g of x. You've got to figure out what happened. So here's what f of x started out as. It moved over to the left 2. So I'm going to write that left 2, and then it moved up 1, 2, 3. So it moved up 3. So that means I'm going to have 2 things that are going to happen. I'm going to have to put 2 numbers in there. So it was just plain x squared. Well, because I moved it to the left, I'm going to have to put 2 in with that x in parentheses. But remember, it's going to be the opposite. So it's going to be x plus 2 squared. And the up 3 tells me I'm just going to add 3 on the end. Number 9 says if g of x equals 1 over x squared, we're shifted 2 units to the left and 3 units up. What would be the new equation? Well, if I wanted to shift it 2 units to the left, I'm going to have to put that 2 in with that x. So it's going to become g of x equals 1 over, instead of x squared, it's going to be x plus 2 squared. The plus 2 comes because I shifted it to the left 2. And then I shifted it up 3, so that means I'm going to add 3 to the end. So this would be our new function.